Hi, I'm Ryan Cook. In this video we will be demonstrating the steps to deploy Pacman across multiple OpenShift 4 environments using the Federation operator from OperatorHub. Let's get started. The first step is to create a project in the OpenShift UI for Pacman. The next step will be to go to OperatorHub and find the Federation operator and click to install it into our environment. Click Install and then verify that the namespace defined is Pacman. Click Subscribe and the operator will begin the installation. Admin is the default value for the context in each of the three kubeconfig files. This needs to be changed to reflect the three different environments. Now that the value of context is unique among all three kubeconfig files, we will export them as a variable kubeconfig. We will flatten all of the config files into a single file containing information about all three clusters. We will export the value of kubeconfig again, using the newly flattened file. The context of each one will be used in the subsequent steps. The kubefed2 binary will be downloaded and placed in the bin directory of the current user. Verify the binary is working by checking the version of kubefed2. The version currently being used by this demonstration is version 0.0.8. Before proceeding, we must verify the Federation operator is successfully installed. Using kubefed2, we will establish the first federated cluster in East 1. It is important to note that East 1 is a member and also the host cluster. The value of Pacman will be used both for the values of Federation namespace and registry namespace. Upon successfully adding the East 1 cluster, the next step is to define the East 2 cluster. An important thing to note is that the command is roughly the same. The only item that changes is the context, which is now East 2. The host cluster is still East 1. Specify West 2 as the last cluster to join into our federated clusters. The next step is to enable specific federation types within the federated Pacman namespace. These can include such things as federated services, federated deployments, and any federated persistent volume claims. Before proceeding, it is important to note that the federated clusters in the Pacman namespace are in a ready state. Now that the clusters are federated, we will clone the Federation dev repository and move to the directory of Federated Pacman. Specific files must be modified to run our Pacman application. The first step is to change the value of replica members here to the Mongo database endpoints that we created in the Federation Mongo README. The file for federated ingress must be changed as well. The first step is to deploy the Mongo federated secret. This secret will be populated to all of the federated clusters. Next, we will deploy a federated service. Next, we will deploy a federated ingress object. This will be used to pass traffic back to the federated service. The last step is to create the federated deployment. This will create Pacman pods in the East 1, East 2, and West 2 clusters. HA proxy is used to provide fast failover between the three OpenShift clusters. modify the O1 HA proxy file using the FQDN that we defined in the federated ingress. The O1 HA proxy file must also be modified to fill in the values of routes 1 through 3 to point to the specific clusters. For this demonstration, HA proxy was used to provide fast failover between the 3 OpenShift clusters. Now that the O1 HA proxy file has been modified, we will create a config map to be used by the HA proxy application. Next will be the deployment of a service. This will create an AWS ELB to be used for our application. Last will be the deployment of the HA proxy application. We need to know the value of the ELB associated with the HA proxy service. The next step is to go to Route 53 and associate an A record with our FQDN of the Pacman application, pointing to the ELB that was just created. Now the fun part, playing the game. Take note of the zone, as it may change depending on which OpenShift cluster you are on at the time. As you see now, we have saved our persistent score to the database. The next step is to modify the federated deployment and only run the application in the East 2 OpenShift cluster. As you can see, the replicas for both East 1 and West 2 are 0. Taking a look at the deployment of all the clusters, you see that in East 1 there are 0 pods running for Pacman. East 2 has 1 pod running for Pacman, and West 2 has no pods running for Pacman. When we play the game again, we will note that the zone is East 2. Regardless of how many times we refresh or open with an incognito browser, it will always be East 2, as it is the only OpenShift cluster running pods. Take note that our previous scores still exist, as well as the game we just recently finished. This is because the Federated Mongo application is storing the data. For the last step, we will set the replica value of 1 on each of our 3 OpenShift clusters, in East 1, East 2, and West 2, making it so that each of the clusters will receive traffic in a round-robin fashion. As you can see now, the East 1 cluster is back in rotation. This concludes the demonstration. Thank you for watching.